Thanks for joining. Today, our topic is quality of service, and I'll assure you that today's session and upcoming session, if you do not know anything related to QoS, you will understand 100% about QoS. We'll see the slide deck and everything. The slide deck I have taken, obviously, these are from Cisco, maybe from Cisco Live, maybe from different resources from Cisco training and all. That's why these slides are very good that I'm going to present. And in these slides are itself built in a way that you will understand QoS, the requirement of QoS, why to apply. Now, there are some concepts which may which you think that it is complicated or difficult, but what we'll do, we can slow down our pace. We'll try to understand, and once you tell that, okay, I understand this, then we'll move. So let's start QoS. The first question related to QoS, that why we need quality of service. That's the question number one. Why there is requirement related to QoS. And now here you can see that we are applying quality of service for these purposes. So what is the purpose? Manage packet loss. It's not only that we are managing the packet loss, but if you have some dedicated services and you want to deliver those services, such as rich media applications, such as real-time applications. So obviously, if there is any congestion uh, in the service delivery, packet will start getting lost, and you don't want that. So you will try to do some arrangement. You will try to do, or you will try to use some of the QoS tools to make sure that packets are delivering. We have less packet loss, or if you have packet loss, you have some other arrangement to resend them. You will utilize the whatever bandwidth you have in between endpoints. We'll see that we can go and apply the QoS in two places, over the LAN link, over the WAN link. So how we are applying, everything you'll come to know. So here you can see the primary goal of quality of service. Clearly you can see as the primary goal is to manage the packet loss. And then the secondary role or goal of QoS is that you can go and classify the packets, is to condition traffic at the access edge. So you can go and use the trust policy. We'll see what does it mean by trust. You can go and do the classification and marking. You can go and do the policing. Right. So the QoS2 goals, first goal is to manage the packet loss, and second thing is to do the classification and marking, that conditioning the traffic to the access edge. Access edge means obviously it will be your LAN part, and this part that you are seeing, the goal number one, it will be mostly, it is related to WAN, because where you have packet losses, suppose you have one branch, you have other branch, and in between these branches, if you have ISP, suppose cloud is there, and then you may have your access switch where you have your LAN network. So when you see the arrangement, if you see the network, so from one branch to other branch, your network is moving. So you have your network from one branch to other branch, and then where you can apply, you can go and apply the QoS on the WAN link. You can go and apply QoS to this link also. Even you can go and apply the QoS to this incoming interface as well, but it will be your trust boundary. We will see that how we can go and create the trust boundary. But yeah, one leg is going towards the LAN and one is going towards the WAN. Now, this is one of the diagram. It's not exactly actually, it's not the exact diagram that we have in the enterprise. Maybe you have other routers as well before reaching to LAN. So you will pick that on which particular interface you will go and apply the QoS. In the LAN network, we know that generally we are applying QoS to the distribution switches. Okay, we'll see that. So here you can see the diagram. I told you earlier that there are so many nice diagrams here taken from Cisco. And in these diagrams, what you understand from this diagram? This is simple, very easy diagram. What's the problem in these diagrams?
There's I think one point of failure.
Point of failure, yeah. And why we have failure? Because you will see that you have fast sender and then you have slow receiver, or maybe you have the issue related to bandwidth. So suppose if this is okay, so if this is, you can see in the diagram, this is 10 gig link, but this is my 10 gig link, right? And this is also, and this is, suppose this is 1 gig, for example. But you can see 1 gig into 11, that means 11 gig. So sending is speed is 11 gig here from, because it is the aggregation from all the different interfaces. And then receiving end, so in this end you can see that your maximum throughput is 10 gig. That means you have 1 gig loss if all the system will send with 1 gig speed. Or maybe if you have 100 of laptop in the access edge, and 100 laptop means your requirement means you can send 100 gig of traffic, but here you have only 10 gig. So that's called what you can say, fast sender, slow receiver type of issue here. Now, this is related to laptop, one laptop, very easy, a straightforward diagram. But you can see the other diagram here. In the other diagram, it is showing here that you have the access switch connected with the distribution switch. So you have your access switches, and then you have one distribution switch here. You can see the point of failure, because obviously why these things are happening. The simple reason behind this is this, that you're sending the traffic in a higher speed, that one link in between the network is something which is slow link, or which has less bandwidth. So there your packet may start getting dropped. And again, this is very simple diagram. In the network, you will see that you have cluster of chain of switches. So what is your point of failure? You don't know. What is happening in the poorly designed network, that people are connecting Cisco switches and in between they are putting some other switches as well. What they want to do, they simply want to extend the network. And in that case, they are putting the unmanaged switch in between the network, and that unmanaged switch will become the black hole for the entire uh, network. So whatever connected with that particular system, right? So those things are there that we have to go and find out how it is working, and where is the problem. Now, I told you earlier in the previous session that QoS is something very much hardware specific. So QoS actually has two parts. One is software QoS and one is hardware QoS. A hardware QoS and one is software. Now, obviously, in software QoS, you can go and use different type of tricks and techniques. But in hardware QoS, this is something like your, you can understand very easily. So if I go and draw one router here, so in this router, there are two things. The packet is coming, right? And then packet is leaving. So when packet is leaving to this particular router, obviously over this particular interface, this will go and use the line rate or the interface rate of that particular router, and you can mark this interface as a egress interface, outgoing interface, right? And when the packet is coming, hitting here to this router, then it will go to the internal cycling or router process can go and use that particular packet. So you can go and apply the software queue. So when packet is coming, incoming packets, you can go and use software QS, right? And in the outgoing, here you can go and use the hardware QS. So this thing should be very much clear that incoming packet and outgoing packet, according to that, we can go and use different type of techniques. So you can see that different hardware having different QS, software versus hardware QS. What is the global default setting? We'll understand this. What is the trust boundaries? We'll see that trust boundary as well. Logical versus physical interface means where you're applying the QS. Mostly you'll see that we are applying to the physical interfaces, but if you have DMVPN technique, like you have one hub and you have multiple spokes, in that case you will go and apply that to the tunnel interface. Tunnel interface is nothing but your logical interface. Then what is the mechanism that Cisco is using? Cisco is using network-based application recognition protocol, NBAR, and NBAR can go and recognize 1400 plus applications.
Mhm.
Now this NBAR is actually, it's like a revolution in the networking domain. Why it is, I will explain you about this. And then you can go and apply to the ingress and egress queuing. So before moving anywhere further, I just want to explain you about NBAR, network-based application recognition protocol. And you will see that Cisco is telling that they have NBAR too. Now, just for NBAR, if you have time and if you go and search Cisco Live documents and all, or any online document, you'll see that just to understand NBAR, you may have 50 to 60 slides. Behind the scene, in the hardware, in the ASIC level, how this NBAR is working, uh, uh, how they are identifying the applications. And then once you identify the application, then you can obviously apply the policy. Now, I told you this NBAR is very important because NBAR can understand application metadata. Now, why this application metadata is important? Because when we are telling that it can go and understand 1400 plus application, what does it mean? 1400 different application means it can understand FTP, it can understand HTTP type of traffic, TCP based originated traffic, and line is big. Now, if someone has to understand different type of applications or protocols, that means that protocol should capable enough to understand the nature, right? Nature of that protocol. And that's why their nature is like they are not reading everything in the TCP or HTTP or FTP, but some part of that, some important part of that. So they will recognize the application. Now, to recognize the application, obviously, router or switches, their CPU cycle will increase. Now, suppose if you are sending 1400 different applications and someone has to understand how they will understand because they have their processing cycle, they have their CPU cycle. From there, they will understand the metadata of that application and they can recognize the application. Now, once the system will recognize the application, then next phase, you can go and apply all new things. So if you go and study Cisco SD-WAN, you'll see that the ISR routers that we are going to use for SD-WAN devices, they can go and use this NBAR. And once they can use NBAR, they can go and recognize the application. Once they recognize the application, then you can go and create new type of things. New type of things is you can go and create application aware routing. Not only application aware routing, but you can go and use application aware firewalling techniques. Okay. In our case, that in our DNA or DNAC, all the switches, basically new switches like 9300 or 9000 series switches, Catalyst 9000 series switches, they can, where you can go and enable this NBAR. Once you enable this NBAR, there also they can go and understand the application. So application aware recognition they can do, and once they do application aware recognition, they can plot different type of charts. Like in this case, you will know that which particular user is using, for example, Facebook or YouTube, how much bandwidth they have downloaded or uploaded. All those application, you will, the DNAC will go and provide the report related to that. It means they will go and plot different type of nice visible charts. Okay, and that's one of the revolution we have actually in the networking domain, so that your system, your switches, your routers, your firewalls, they can go and identify the application. Because if they do not identify the application, how they will apply the policy, right? And this application awareness is actually, it's like old technique. It was there in the checkpoint firewall, Palo Alto firewall, now FTDs, all these firewalls. You think like this, if they do not understand the application, how you will apply the policy? So they have this mechanism to understand the application with their metadata, right? So that is one of the very important aspect. So what we have done so far, that we have discussed that the need or goal of QS, two goals are there. You can go and apply to the LAN interface and WAN interface that we have discussed, point number one. Then what we have discussed in point number two, that you have software versus hardware QS and the directions. We can go and apply the QS to the ingress and egress. Then third thing, we are discussing about NBAR. Okay, so knowing these very small things, let's move on and see what we have, even the requirement and all, what we have here in the slide. Now, because this is easy to start, the trust boundary concept, and such type of concept we have in our lab as well. So the big lab we have, right? The CCI big lab. In that you will understand we have the security features as well, like DHCP snooping. And once you apply DHCP snooping, then where you will go and apply these policies. So those things will come later on. Now in this diagram, first of all, try to understand that where you are going and fixing your trust boundary. What is your perimeter? So very easy, from the diagram we can understand that some places we can go and make our switches. So you can see that on top, that switch is connected with the switch is connected with printer, switch is connected with laptop. So you can go and define the trust boundary. You can say no MLS, QoS trust, untrusted, means you can go and define the trust boundary for the, at the switch level. Then you can see that even we can go and extend that trust boundary and apply the trust boundary to the PC level, or maybe any other virtual conferencing type of device is there, or maybe any switch is there. We can go and apply there. We can go and apply the trust boundary to the VC conferencing devices, or maybe telephony devices. So you can see that you have the trust devices. If you go and type the question mark here in this Cisco switches, MLS QoS trust, device question mark, you will get option related to you want to define the boundary to the Cisco phone, CTS, IP camera, or media player. So here you can see in the um, configuration, these are the configuration step. MLS, QoS, trust, DSCP. Now, what is DSCP? What is COS? We'll discuss. Today only we'll discuss. You can see that if you go and apply the marking, see classification and marking. So if you go and apply the classification and mark, basically they are related to marking. So if you go and apply the marking at the layer 3, then you have to go and use DSCP, differentiated service code point. If you go and apply the marking to layer 2, you have to go and use the COS, class of service, right? So you will understand, we have very nice slides explaining that what is COS, what is DSCP. Marking are accepted or rejected. You can apply the marking and then you can accept or reject. Very easy concept. The important thing we have to understand about the COS and DSCP, we'll understand this. So now in the next slide, you can see the trust boundary and the marking. And now this table you can see here. So a little bit difficult to understand. So what we'll do, first of all, we'll go and understand about COS and DSCP, and then we'll come back to this slide. So you can see I took taken this slide somewhere from the internet, and I have put here in this slide, in this PPT. Now you will see, now you will understand this COS and DSCP. So if you go and check IPv4 header, if you go and check IPv4 header format, hmm, okay, identification, offset, protocol header, where it is, ECN, DSCP, yeah. Still it is not what exact, yeah. Okay, two formats I'll show you. First, see this. This is IPv4 header format. Now here you will see somewhere type of service, TOS, right? You can see on top, I think 4 byte of this, so version is maybe 2 and then 4 and 4 plus 16 like that. Maybe. Okay, so you can see this type of service field here. Now let me go and show you this in little bit extended format. This TOS is further divided into, you can see this DSCP and ECN, explicit congestion notification, ECN, DSCP and ECN. Now it is starting from bit number 8 going to 16. That means they are 8-bit field, right? Maybe 2 bytes, 8-bit field from 8 to 16. Now you can see that it is part of IPv4 header format, right? Now let's go back and let's see this. So the type of service that we are talking here, the type of service that is TOS, that is part of IPv4 format. Now you will see that TOS actually having, so you have TOS type of service. It may be you can go and define it at layer 2. So if you go and define to layer 2, it will become the COS, class of service. And if you want to define at layer 3, it will become DSCP, differentiated service code point. You can see the differentiated service code point, right? You can see here COS, DSCP. TOS is type of service, a part of header. Then rest of the things are very interesting. And finally, in bottom, you can see ECN. This is 3-bit field. So this 3-bit ECN field, and here also you can see this ECN. This is 3-bit explicit congestion notification. What does it mean? We'll see that. But before ECN, let's go and understand these terms here. So you can see that AF, IP precedence, CS, DP. These are the terms that will be used within the quality of service. If you are studying quality of service, these terms will come. Okay, so first of all, you separate the service, like you have layer 2 service, you have layer 3 service, and then according to that, further you can go and study. Now, this costs. There may be chance that the device do not understand DSCP, layer 3 services or layer 3 QoS. Then you will go and apply the costs, class of service. Now when we are talking about costs, you will see that this here, this is actually a very nice diagram. So you can see first of all TOS, and then you can see DSCP, and then you can see cost. Cost is equal to IP precedence. Now for cost, you can see clearly that we have bit 1, 2, and 3. Actually, 3 bits are there, and those bits are 6, 7, 8. So total how many bits are reserved? So for DSCP, you can see the bits they are reserved. Actually, 1, 2, 3, 4, 5, 6. 2 bits are there for ECN. Okay. So if we have combination for 2-bit, 2-bit means it may be 0, 0, 0, 1, 1, 0, 1, 1, right? If you have combination for ECN, so bits will be like this. So 0, 1, 2, and 3. Now what it is telling, first and second bit. So if you see this big chart here, in this big chart, you will see that we have all the 8-bit. 1, 2, 3, 4, 5, 6, 7, 8. And when you are reading this chart, first and second bit is always 0. That why it is 0 means in this chart it is 0, but it should be, maybe it is 0, 0, 0, 1, 1, 1, etc. We'll discuss about that. Now in this chart you will see that the priority. If you understand this particular term that I'm going to use here, you will understand most of the thing. So you will see this application. Oops. You see here this application box. Let me go and change the color. This application box here. Okay. Now you will see when you are creating the QoS, you are dividing. You have to go and classify the applications. Once you classify the applications, then in segmentation of applications. So in your organization, maybe some of the applications, they are high priority traffic. Some of the applications, they are low priority traffic. That's the reason you can see here the classification. So you have best effort, scavenger, bulk data, network management, transaction data, call signaling, mission critical, interactive video, voice and routing. Some of the control traffic, control plane traffic, that will be very critical, because if you're routing, suppose OSPF control packets will drop, OSPF will not form. If your STP, spanning tree control packet will get dropped, the STP will break, right? So there are some control traffic as well. We should give high priority to them. Now you can see in all the classes, like it's a low priority traffic, or maybe high priority traffic, or maybe mission critical traffic. So further you can divide in 3 parts: low priority, mid priority, and high priority traffic. Now here you will see clearly that in this part also you have low, medium, high, low, medium, high, low, medium, high, low, medium, high, right? What does it mean? Again, I will explain you. Don't worry about that. We are going to learn everything. Now, in this diagram, you will see that costs, right? Costs, where it will be your 6th bit, 7th bit, and 8th bit. where you have 6, 7, 8, this particular highlighted diagram. So when you have 3 bits, right? And with that 3 bit, if you have to go and create the arrangement, how you will do 0, 0, 0, right? With 3, how many combination will come? 3 into 3, I think 9, right? 1, 2, 3, 4, 5, 6, 7. I think I have missed something. So 0 is done. 0 then should be 100. Oh, I missed this thing. 1, 1, 0, right? Like that means it should be not. Here you can see in the this diagram, you can see. Let me go and erase this. You can see 0, 0. Oops. This is okay. So you can see 0, 0, 0, 0, 0, 1, 0, 0, 1. I don't know why they have given 0, 0, 1 3 times, but this is one arrangement because low, mid, and we'll discuss. But again, you can see 0, 0, 1. You can see then this. So here, how many combinations are there? 1, 2, 3. Because you can see colors as well. Different colors are there. So 1, 2, 3, 4, 5, 6, 7. You can make 9, right? Simple mathematics, right? If you have 3 bits, how many combinations you can get? Can you help me to get this? Then 0, 1, 0, right?
Yep. Then 0, 1, 1,
0, 1,
1,
1,
1.
right?
Then
Then
1, 0, 0,
1, 0, 0,
and 1,
right?
0, 1, and then 1, 1, 0, and then 1, 1, 1.
So how many this is?
Yeah.
1, 2, 3, 4, 5, 6, 7, 8. Okay. 8 only. I
Yeah.
think we can create only 8 combinations. That's why I can see here in this chart. If you see this chart, you have 8 different combinations. So 0, 0, 0, 0, 0, 1. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah. You can create 8 combination. Okay. Now, if you go and see this diagram, this, you will find little bit difficult because what they try to do that they want to explain everything in one diagram. That is good also. So you can compare different services at one place. So this particular highlighted portion that you are seeing here, this portion, right, that you are seeing here, this is COS, class of service, or IP precedence, right? Then for DSCP, how many bits you have left? So for DSCP, you have 1, 2, 3, 4, 5. 5 bits. Actually, technically, you have 5 plus 3, right? So for DSCP, you have 8 bits. With 8 bits, how many combination you can create, 64, I think. 64 combinations you can, I think, go and create for DSCP. But what Cisco and other vendors they have done, they haven't created 64 combination. You can see in the bottom DSCP, maximum it is going to 56, right? So they are starting with 0 and then 8 and then 10, 12, 15. It's actually very interesting. This chart is very interesting. Now we can understand this little bit, right? So before I go to DSCP, are you able to understand this this particular section? This
Exactly,
is
though.
layer 2. If you are doing layer 2 marking, you have to do COS or IP precedence. This is for layer 2 marking, right? Then you have layer 3 marking, and some places you will see sometimes you have to go and map the layer 2 marking with the layer 3 marking as well. Now these markings, if we do not think this marking as a marking, but if we go and think this marking as a tool that we can go and segregate our traffic and then apply the marking. So you can see that here in this, how many segregations are there? Best effort. And then you can see the color. This is actually very interesting. So 1, 2, 3, 4, 5, 6, 7, and 8. 8 different color you can see here in this spectrum. And this is actually Cisco best practice. So when you are also creating your QoS policies, then you should know this as a base reference, this chart. And according to this chart, you can go and put the applications inside the best effort. So you created one class, best effort. Inside that best effort, you can go and put Facebook, YouTube, Twitter, all those social media and other gaming profiles and all. Those are best effort. Means you are not going to give any priority for best effort traffic. If they are delivered, otherwise no one cares. You got the point for the best effort. Likewise, scavenger and the bulk data. They why we have such arrangement? Because we don't want any type of priority guarantee for these traffic. If they are dropped, it's okay for the business, right? So now if you have to go and apply only layer 2 QoS, so then you can go and use this arrangement. And for best effort, you can see that you can go and simply use 0, 0, 0. That means nothing but 0. So for best effort, the cost marking is 0. For a scavenger and bulk traffic, and like that, in that spectrum, the cost marking is 1. So if you are putting marking 0 or 1, you can understand why we are having this arrangement, right? Any doubt in this? You are able to understand?
Yes. So my question is, how do we then configure this? Do we have a
We'll see
configuration
the
example?
configuration.
So
Yes.
when today, tomorrow?
Today, I think
Next
it's not
class?
possible. We have full-fledged lab as well, but later on. But configuration example here we have in this slides.
So we're gonna
How
practice the configuration, or we're just gonna look? Because I
we
want to be
haven't
able to.
started the lab. Lab will start. Once the lab will start, 100% we have configuration for these things. This
Yes,
configuration
because
that you are seeing, that we
yeah.
have actually this configuration in our SD1 session, and once I'll start the lab, I'll configure this. Configuration is actually very easy. It's
Okay.
very easy to configure this, because once you understand this concept, this is the configuration. So I told you that you can go and create the class. Inside that class, you can go and match the group like WhatsApp or Facebook or YouTube and all those things. And according to that class, you can go and apply the policy. You'll understand. I'll come to that. I'll not go ahead of time, but you will understand everything. Now, if I put and see here, what is the class voice and what cost we are putting? 5, right? This cost. Now, if I simply go and give this command, okay, match QoS 5, what you will understand now. But if you go and check this chart, you will see that 5 we are using for voice, right? In the costs. So now you will understand that in the CLI, why with the class, this is class, why with the class voice we are using 5, right? Now you will understand this configuration. Simply if I go and give you the configuration, these configurations are very easy. Never, never worry about this configuration and all. Signaling, why we are giving 3. And this is related to costs. But if you go and use DSCP, so in DSCP for voice we are giving EF. I think this is explicit forwarding, EF. So for voice, cost is what? 5. For voice, IP precedence layer 3 marking is EF. Why? So again, if you go back to the chart, you will see here that the DSCP. So the first portion is in this diagram is the costs. And then this part is nothing but actually both. If you combine both cost and this part, actually this will become DSCP. DSCP is from here to here, right? Because this part is ECN and it is always 0. Always 0 means no congestion. Again, I'll explain you ECN. It is little bit different. I will explain you in the QoS section itself. But you can see that this particular portion, this portion and this portion. So how many bits? 3 plus 3, 6 bits, right? So 2 to the power 6. How many combinations? You can understand. I think 64. 2 to the power 6, how much this is? You can say, oh, 32. So 32 combination you will get related to DSCP. But 3 of the bits you can see, they have the similarity. And how you're mapping this 3-bit to 8-bit, that is one other story. So layer 2 marking can be combined with layer 3 marking, and that's why you'll see there in the configuration. While for VoIP, the DSCP marking is EF. EF is the highest marking. We don't have anything above EF related to traffic. And then these two rows that you're seeing here, they are related to control and signals. They are mandatory. You have to give queue for your OSPF control packet, for your STP control packet, for your EIGRP control packet. This is for networking. This is mandatory. You have to give the CS6 and CS7 for very high traffic, high priority traffic. Otherwise, network will break. Suppose if you do not allow OSPF control packets to flow, how OSPF will work? They will never form, right? So don't worry, we have configuration. I know that you are waiting for, something to do CLI configuration and all. And I'm telling, okay, wait. This wait time will get over, don't worry. Then we have only configuration and lab. Okay, so far it's okay? You're able to understand?
Getting it gradually though.
Yeah. Okay, so no problem because see, I haven't covered this. So today what I have done, I have covered 1, 2, 3. I haven't gone through this 4, and we are in the 5th slide. And 1 hour is almost over, means we are approaching. That's why if you understand this concept, it will help you always to understand QoS. Understanding this QoS, this marking is actually very important because this is very much like mathematical. What we are doing here, we are understanding the maths, the mathematics. That's why you're feeling this. Now, once you understand this IP precedence or cause that is nicely highlighted in this section, then if you want to add the layer 3 marking as well, what you need to understand, you need to understand these both together. From bit number 3 to bit number 8, you have to understand. Right now, because we understand very much, we understood the flow. So now you will see that you have your best effort, your scavenger, bulk traffic, and your other fields are here. Why it is there? Because not only we want to mark this 0 and 1, So these zeros and ones related to what? Cos bit. If you go and put this in the uh, DSCP, so DSCP bit will be 0, 8, 10, 12. Why and 14? Why this is 0, 8, 10, 12? Because very simple. If you go and add these bits, so let me go and highlight this. For example, if you go here in this and if you calculate this 0, 1, 1, 1, 0, 0. So 0, 1, 1. Clearly it is telling that you have to go and add 4 plus 8 plus, sorry, 1 plus 2 plus 4 plus like that. So 0. So you will not add because this is 0. So 1, 1, 1. So that means 2 plus 8 plus 4 plus 8. How much this is? 8 plus 4, 12 plus 2, 14. That's why you will see 14 here. Now, for example, I'll go and randomly choose anything. So for example, if I go and pick this, what will be the DSCP value? If we have such type of bit arrangement, so 1, 2, 3, 4. That means 1, 2, 3, 4. 16 plus 8. How much? 24. Plus 4, 28. Plus 2, 30. So if you see the DSCP here, this is 30. Right? Like that, if you go and add this EF, this bit here, it will come 46. You have to go and add like this. So it's not like that you have to go and add always, and you have to understand this. That's it. If you understand, you don't need to go and do all these maths always. You have to understand this once and you will use always. Now, one very important thing here is this. It's very important. That's the last thing to understand in this puzzle is this part. Drop preference. This DP is drop preference. So you think like this. And this is not a good example, but again, I am giving this example. Suppose you have 3 ambulance, for example, 3 ambulance are there, right? And you have to pass 3 ambulance at a time. And you have this option, means you can't allow 3 in the same time. You have to go and give ambulance 1, ambulance 2, ambulance 3, one by one. Okay. So you have ambulance 1, ambulance 2, and ambulance 3. But problem here is this, that you have to pass them and one by one they can go. So because since they are ambulance, right? They are same class, right? But still how you will go and give the priority? So suppose in one of the ambulance we have the president. It's a bad example, but still. So I will not give president. Say the ambulance is there, but maybe very critical situation. Somehow we come to know that the patient in that ambulance having very critical situation is a little bit less critical, and the other ambulance has low severity, or it is less critical than all, right? So that means that you will go and allow this one first, and this one second, and this one third, right? But there is still part of ambulance community. They are ambulance. That's why you will see that although you have same class, but is still with a DSCP, you can further divide the traffic. Because in DSCP, you have more bits, right? You have 6 bits to further subdivide the traffic. So even they are same class, still you can go and define the low, medium, and high within same class. And that's why we have this AF. AF is nothing but assured forwarding. AF, assured forwarding 11, 12, 13. So that means if AF 1, 1 is there, 1, 2 is there, and 1, 3 is there, that means 1, 1 is low. So as per the low, it's mid. Oops. And it's high. Likewise, you will see that you have AF in 2 as well. You have AF in 3 as well. And you have AF in 4. That means further you have 4 different classes as per the costs. And below you go in this chain, they will become more and more critical. Right? This is like this. Further you go means 11, 12, 13. So they will become critical. So you have actually this principle in QS, top to bottom and left to right. In the same class, the left to right will become critical, and in different classes, top to bottom traffic will become critical. Okay, so knowing this much knowledge, I will not further go and continue the class. Your task is this, that simply go and check this first 10 slides. That's it. Try to understand from your perspective and ask question in the next session.